Hey everybody, and welcome back to Jim's Garage. In this video we're going to be looking at a NAS, that's Network Attached Storage. This builds upon the previous videos whereby we've set up a home lab server, we've installed a hypervisor, we've done some networking, and we probably want to have some dedicated storage on that network. The benefits of having a NAS are manifold. You don't just have to have your data backed up on the device you're currently on, i.e. this computer I'm recording on, maybe a laptop, etc. You can have a centralized storage location on your network. That means you can share that with other users, and it also means that you can access it from any device. It often has benefits as well through things like RAID, whereby you'll have multiple copies of your data for redundancy. So in this video, I'm going to talk a little bit about what NASs are and what to look out for. I'll give you a few recommendations of off-the-shelf products that I recommend, also the ability to build your own NAS, and then we'll have a look at deploying a NAS software solution. I'll be using TrueNAS in this video, but do note that there are others available. After this video, I am going to be reviewing a couple of NASs, which hopefully are ones that I recommend, so stay tuned. But before we go any further, a quick word from today's sponsor. Brilliant is an interactive learning platform that helps you master concepts in maths, science, and computer science, and others, not by just memorizing facts, but by actively doing. It's also been curated by some of the top professionals in the world, from leading academic institutions and also some of the leading tech firms. It's a perfect problem-solving platform designed for people who build things, engineers, devs, data scientists, and curious minds like you and me. They break down complex concepts from recursion to machine learning into bite-sized interactive lessons. It's not passive learning, you're hands-on from the first minute. I've been using Brilliant to revise some of the core CS concepts and improve my math intuition for writing better code and debugging faster. It's way more effective than scrolling through Stack Overflow rabbit holes. Whether you want to understand what's happening under the hood of your machine learning models, level up your algorithm skills, or just finally get a grip of linear algebra, Brilliant makes it intuitive and visual. If you build, automate, or optimize for a living, you need tools that sharpen your thinking. Brilliant does exactly that. I've been using it now for a couple of weeks, and I'm really impressed with how much it's improved my learning capabilities. The courses take you step by step, starting from beginner up to advanced, and you can choose where you want to start on that journey. Everything builds upon the previous lesson, so you never feel as though you're out of your depth. To try everything Brilliant has to offer for free for a full 30 days, visit the link on screen, the QR code, or check the link in the description. You'll also get 20% off an annual premium subscription. First and foremost, you want to think about how much storage you actually need, because that will have a trickle-down effect on basically the size of the device you buy, its expansion options, and also things like the connectivity, i.e. how fast you want to be able to access this device. Now, there is an option as well to use a NAS more as a home lab server, i.e. something like an all-in-one. But in this video, I'm just going to speak about having this as a discrete device specifically for storage. The benefits of that can be that you can actually minimize the setup for that. You can have a smaller, more cost-effective device. And recently, there's been an explosion in the home lab NAS scene. Now, most people are probably only going to require a few terabytes of storage. And you have the option of either doing it through NVMe drives, which are fast but smaller and you get less value for money in terms of pound per terabyte, or you can go the more traditional 3.5-inch hard drive approach. Those are slower devices, however you get much better value per terabyte. But it will impact the size of the device, and that could impact therefore the scalability of the device as well. And there are some advantages to just using the NAS as a NAS, i.e. the more things you run on it, the more likely something is to go wrong. Probably not an issue in the home labbing space, but definitely something if you were in a more production environment where typically you would have a dedicated SAN network just for storage on its own, not running any compute. Once you have an understanding of how much storage you need to think about how you're actually going to achieve that. Are you going to be using sort of flash-based storage, or are you going to be using the more traditional spinning Rust hard disk drives? Both of those approaches have advantages and disadvantages. We all know flash devices, they are really fast, but they're also small, so they give you comparatively less value for money at a pound per terabyte perspective. The converse is true for hard disk drives. They are much larger, much better value per terabyte, but the performance of the drives is much worse. Now, depending on what you're going to use the NAS for, that might also dictate that decision. If you're using this solely for backups and storage, then access speed probably isn't an issue for you, especially not intensive IOPS. The issue of IOPS though is definitely something you need to consider if you're going to be using your NAS sort of in real time, i.e. something like video editing like I'm doing here. If I want to be storing in real time and doing some proper real-time scrubbing, etc., I really need some fast IOPS on my NAS, which leads nicely into probably the next main consideration, which is going to be the connectivity of the NAS. Now, on cheaper devices, you're probably going to be stuck with a 1 or a 2.5 gigabit NIC, and for most people that's going to be fine, certainly in that earlier scenario of if you're just going to be using this for archiving data. But anything you want to use in real time, you're probably going to be looking at 10 gig minimum. And that does a couple of things. It changes the products that are available to you, and it also increases the price. As you're getting up to 10 gig, you're entering more into the sort of semi-professional space, and we'll look at some devices soon that reflect that price change. The benefits of having 10 gig are obviously you're going to have snappier connectivity to the NAS, i.e. faster data transfers and access. And certainly if you're going to go down the NVMe route, faster makes a lot more sense. One other thing to consider is the operating system of the device, and whether you want something off the shelf that's often proprietary or something that's open source. That gives you much more flexibility as well. So things like the Synologies, the Ugreens and the B-Links, they often will have their own operating system that you can run, but you can often change that. I would strongly recommend reading up on whether you can change those in the future, because it's more likely that as you become more advanced in your NAS and your home labbing, you probably want to be able to repurpose your device and fit it to your exact needs. The ability to put something on it like TrueNAS or Unraid, or hey, even just build it yourself through something like Debian, is a great ability to have, because you can really dial down on exactly the things that you need, and it behaves more like a traditional operating system or PC, whereby you can start upgrading the components. Another item to consider is the notion of whether you want ECC memory or not. Now, if you're going for cheaper devices, typically it won't have ECC memory, which stands for error correcting code on the chips. Now, there's a lot of debate about this, about saying whether do you actually need it or not, and I'm not going to kind of fall down on one side or the other. I'll let you do some research on that. Me, when I'm building a NAS, I usually always go for ECC. I think the actual uplift in price doesn't really make it cost prohibitive, but it does limit your options if you're going for an off-the-shelf product, i.e. I built my own NAS and I've made sure that I'm using ECC memory in it. Now, thankfully, you can build things that are cheap and DIY, and thanks to things like AMD including some ECC support on some of their B series boards, that's a great option if you want to build your first NAS with full ECC. The reason I do it is simply because it's one headache I can get rid of, and I don't need to worry about losing some of my files, albeit the odds of doing it are almost infinitesimally small, especially as well with the advent of DDR5, which actually has some on-die ECC, just not the full ECC between the RAM and the CPU. You also need to think about how much RAM you do need. Again, off-the-shelf products are going to have limited RAM slots. You're often going to get a sock where it's soldered onto the board and you cannot upgrade it. Whereas your more traditional PC, you're probably going to go anywhere up to these days, up to sort of 128 gigabytes. And if you're going into the enterprise space, that's now into the terabytes. Obviously, you need to scale that to what size of NAS you want to have. And especially if you're going to be going down the ZFS route, something like that, you do need to provision. There are minimum recommendations for how much RAM you should have per gigabyte or terabyte of storage. Lastly is probably the CPU as well. And it doesn't really matter too much what CPU you're going to be using if you're just using this for storage. The CPU plays into it obviously more if you're going to be using this as an all-in-one home lab server. So let's now have a look at some products. We'll start at the bottom of the stack with some familiar vendors. We'll look at the bare bones NASs, and then we'll move up the stack to medium off the shelf and then the more premium off the shelf. I'll then talk about some of the hardware you might want to consider for building your own DIY NAS before we actually get on to installing and deploying TrueNAS. So, no pun intended, a name that's synonymous with NASs is probably Synology. And it's where I first started out a number of years ago with a similar model to this one here. Now, this only takes 2 drives, it only has a 1 gigabit connection, and it doesn't have ECC memory support. But what it is very easy to use, comes with a proprietary OS, and you can basically just plug and play with this NAS. The hardware specs are nothing to write home about, but as I say, if you just want something simple, you're first dipping your toe into NASs, you want the convenience of off-the-shelf, then this might be the way to go. They do also have other models moving up the stack, so that one's actually a 1 bay. There are 2 bays, 4 bays, and you can basically scale up this through their product stack to whatever it is you need. It does come with their own proprietary operating system, and I do believe on some of the devices you can actually change that, albeit I don't think it's officially supported. You'll see on their devices they actually have a software spec tab, and if you scroll through here you'll see the various configurations, supported RAID types, etc. that it supports. Things that you want to look out for are whether it supports things like trim, whether it supports different file protocols, common things like SMB for Windows sharing, things like NFS more for your Linux setups, and whether there are any limitations around how much can actually connect to that in real time. So for example, this seems to have an arbitrary limit of 5 SMB connections. I haven't tested any of this stuff, by the way, it's just going by what the software vendor says. So I recommend if you are looking at off the shelves, you should check out some of the Synology gear. They do tend to have a decent reputation in this space. So whilst we're in sort of the lower end, more cost-effective solutions, you've probably seen me cover in the past as well some of the Ugreen devices. They do now have a number of NAS devices that are out there. They have things like the DXP 4800, which runs your traditional 3.5-inch hard drives, but they also have things like the 480T Plus, which does support all flash memory. You can see that one over here. Now again, this is pretty much a similar setup, albeit it does cost more, but that is reflected in the performance. Here you can see conveniently on this device, and I've tested this in a previous review, we do actually move up in terms of core and thread count. We actually do get an Intel CPU here. It runs at about 15 watts. We have expansion of RAM up to 64 gigabytes. We also have a 10 gigabit connection and a 2.5 gigabit connection, plus the use of 2 NVMe slots. So this is significantly more expandable than the previous model I showed you, albeit there is an uplift of basically double the price. But I think that expansion and convenience is well worth it if you're looking to go into sort of a medium-sized NAS that has some breathing room for the future. Now this device doesn't support full ECC, but it does support you changing the operating system. Now when I first tested this, the Ugreen operating system could do with a little bit of improvement, but I thought it was a good first foray for a new product. Since then, there have been new releases. That user experience has improved. Things like being able to integrate Docker images directly onto the NAS is really great, and the experience for the user to do that, I found it to be pretty straightforward. Now, looking at another vendor and also looking at another form factor, we have things like the recently released B-Link. Now, I do actually have one of these devices sent to me, and I will be reviewing this in an upcoming video. Now, this is an interesting device for a few reasons. Not only because it's really small and it's really cheap and it uses a very power efficient CPU, it's actually all flash. Now I'm going to wait until I give my full verdict on this, but I'm really interested because you get the benefits of having flash memory, but you get it on a bare bones package. That means you're not having to pay too much of a premium for this fast storage. Now there is one sort of elephant in the room, that it only comes with 2.5 gigabit connections. But that's probably going to be okay. Sure, you're not going to get the full fat experience of something like 3 or 7 gigs, depending on whether you use PCIe Gen 3 or Gen 4, but you do get a big uplift in IOPS, i.e. the operations per second. So it will feel a lot more responsive if you're doing it for, say, things like editing or things where you need continuous access to files. That's going to be better, especially on a hard drive system, whereby once you've kind of consumed up that RAM and the stuff that's stored in the RAM, it's then going to have to go back to reading and writing from disks, which is really slow. So considering the price, B-Link also do have other products in this category. This is another option if you wanted some fast storage, you want it to be cheap, you could go down this route. If you wanted the benefits of having, say, fast storage and you want to spend a little bit more of a premium, things like that Ugreen 480T, where you're going to get basically 10 gig connection and you're going to get 4 NVMe drives, that might be something that you want to go and check out. If you want to go more into the premium space with your NAS, something like the QNAP devices are generally well regarded. These will offer you a more enterprise solution, but also a more enterprise price tag. So as you can see here, we've got a number of bays here. You're starting to move up to U.2 NVMe for their all flash, but they do have more traditional 3.5-inch drives if you want to do that. They have a number of hybrid devices as well, so you can have 12 hard drives here and 4 SSDs, and that can give you sort of a more professional setup where you would have tiers of storage. So you would have immediate fast storage, and then that usually gets archived onto slower storage as and when it's not used. Things like this probably not going to be that useful for your home lab unless you maybe run a business at home, maybe you have multiple people that need access all at the same time. You can see on the left as well that they do tend to go all the way up to 30 bays. So really the sky is the limit on this. The last thing I want to touch on really is the sort of off-the-shelf but DIY as well. Now I do have one of these devices and I'm going to be covering that in the next video, but the 45 Home Lab HL15, yes, it's a premium product, let's get the elephant out of the room, but I've been really impressed with some of the testing that I'm doing. Where this falls in the stack is you could use this as an off-the-shelf product because it does come with their Houston OS, which is a NAS operating system all by itself, but because this is basically just a server in a box, albeit a very nice box, well thought out with great hardware, great software, this could be installed with anything that you want to put on it. For example, you could definitely run this as a home lab server, not just a NAS. There's enough horsepower in here, especially in the one that they sent me. You could put 20-core CPU in here, you could put terabytes of RAM in here, it's got multiple PCIe lanes to extend this out, and you've also got 15 drive bays in this machine to basically build a NAS. You could then stick Proxmox on here or any hypervisor you want as per earlier videos, and you could actually build a virtualized NAS in here while still having plenty of grunt left over for virtual machines and even with PCIe pass-through, things like a graphics card. Now obviously something like this is going to be catered more for if you have say a rack or you at least have a dedicated space for some storage. You can see here you can actually run it as a more traditional tower, but I think the intended purpose for this is certainly for it to be rack mounted. So do bear in mind the size of this device and also the heft of it. But if you want my recommendation, I would basically take this device as a blueprint. Personally, for me, the whole attraction of home labbing is that DIY element. I want to build something that I want to fit my use case, i.e. it needs to be flexible, it needs to be expandable, and it needs to give me an opportunity to learn. Now we'll dive more into this in a moment around some of the components you might want to consider, but almost use this as a blueprint for some of the things that you're looking out for. A product like this is going to basically give you a test bed of everything that you would probably need. It's going to give you full ECC, it's going to give you expandable memory, it's going to give you fast storage options, not only on the motherboard itself, also fast networking on the motherboard itself, but also a more traditional PC experience where you can expand the peripherals via PCIe lanes, i.e. do you want to stick 100 gig on here? Sure, stick it in the PCIe slot, you've got 100 gig. You can then put that into the rest of your network. Do you want to add more drives to this? Sure, you can add some fast NVMe drives into this and you can build up that tiered storage like we saw on the QNAP devices. Now I've covered making a DIY NAS in the past, and most of the things I've discussed in that video are still relevant. So in that build I used an AMD machine. The reason I used that was because that B450 supported ECC and also the CPU supported ECC as well, plus it had integrated graphics. Now, you might not need integrated graphics, but it's something that if you can get it, why not? If you go down the Intel route, usually those are superior to the AMD ones, albeit that is improving generationally. So as a bare bones NAS, I would recommend something like use your old PC, an old PC case, buy one off eBay, find one in a charity shop, whatever it might be. If you can really stretch to something like an ATX form factor, you're going to have a lot more expansion opportunities. You can use an old PSU, doesn't need to be anything flash. Remember, if you're just using this for storage, it can be as low as 200-300 watts. Realistically, it's going to be 500 watts. That seems to be the minimum size. In terms of a CPU, determine whether or not you use ECC or not, and then just scale it appropriately. If you want to be going something low and you don't care about ECC, even a dual core is going to be fine for you. If you do want ECC, be prepared to move up the stack. RAM, for most people, 32, 16 gigs, that's probably going to be fine for you. Depending on the size of the storage you want, if you're going to be using ZFS, that ARC, that cache, etc., you'll need to scale that accordingly. Networking shouldn't be too hard to get at least 2.5 gigs. That's baked into most modern motherboards these days, and even back a few generations now. Plus, if you just go onto eBay, I've been a big user of the Mellanox Connect X3 cards, which I was able to pick up 10 gig networking for around £30, especially even with dual port ones. So do shop around, there are some absolute bargains out there if you're willing to spend a bit of time researching. So now let's move along to beginning the process of installing a NAS software solution. So for this video, I mentioned I'm going to be using TrueNAS, but why? Well, pretty much for some of the reasons you can see on screen. I've used it for years, and that was based upon other people having already used it for years. It's built upon ZFS technology, which is tried and tested, and it gives a lot of benefits, especially around things like redundancy. The key thing around a NAS is you don't want to be losing your data. So the whole concept of ZFS is built around RAIDs. It's a software RAID, whereby traditional machines would use a hardware RAID. Problem being, if that hardware failed, you'd often be in trouble. Whereas a software-based RAID has a lot of advantages. Now, TrueNAS supports a lot of different operating modes. It can be used as block storage, file storage, object storage, and it also supports different container runtimes, things like embedding Docker, Kubernetes into the stack as well. So, as I've said before, you can actually use TrueNAS not just as a NAS, but you can also use it as, say, your hypervisor. More specifically, TrueNAS uses OpenZFS, which you can see was developed in 2006, so there's almost 20 years of development into this product. In terms of core features, things like snapshots, replication, and self-healing, these are all buzzwords, these are all big thumbs up in terms of what you're looking for in a NAS and what ZFS provides off the bat. For performance, there's lots of advantages as well. Read-write cache performance, security as well, drive encryption, checksum validation for validating data integrity, and equally important is support across common operating systems, Linux, BSD, etc. Now, if you're going to go down the ZFS route, which I do recommend you do, but take at your own time, you're going to need to get familiar with some of the common concepts that you can see on screen here. Now, I've covered this in a previous video, so I recommend you do go and check that out as well, but I'll give you sort of an overview of what it means in its most simplistic terms. There is some late night reading around this huge page document that you might want to go and actually check out. I do find it quite interesting. But the way in which it really works is, I've already mentioned, this is a software RAID. So the process of a ZFS is that it breaks up your physical devices into virtual devices, whereby lots of independent hard drives will actually make a virtual device. So for example, you could have 3 hard drives that make one virtual device. And then that virtual device, and you can have many virtual devices, will make up pools. Now the idea is that no single drive is going to cause an outage, and depending on the different levels of RAIDs that you have, RAIDs and then the number, RAIDs 1, 2, 3, etc., denotes how many drives can fail before you get data loss. So that's definitely something you need to think about when you're trying to provision your NAS. Do you want 1 drive, 2 drive, 3 drives of redundancy? Personally, I go for 2. But again, obviously then you're going to have to get 2 drives that are effectively not really doing anything, i.e. in terms of they're not going to contribute to the overall storage space of your NAS. What it does mean as well in this concept is not even just the drives that can fail, you could also have different pools, volumes, etc. as well. You've got redundancy across those. And the way it works in a very primitive fashion is that it essentially creates copies of the data across all of the drives, such that if any of those drives fails, the other drives should be able to compensate, i.e. they have copies of that data available to them. So as I mentioned, there's some good resources here on the official website around what exactly this is, and I recommend you do go and dive into it. But to actually get started with TrueNAS is pretty straightforward, and it's actually free. So we can simply go to Get TrueNAS, and we're going to download the Community Edition. Obviously the Enterprise is designed for Enterprise and comes with a price. Now, if you're new to TrueNAS, you're probably going to hear about things like TrueNAS Core versus TrueNAS Scale. Now, I traditionally used TrueNAS Core, but I think that's now been retired, or at least more development is going to be put in TrueNAS Scale. So I actually moved over about 2 or 3 years ago for those reasons. Plus, under the hood, it's moved to being Debian based as opposed to BSD, which I'm more familiar with. So we're going to download here the TrueNAS Scale. So it's as simple as just clicking on the link and waiting for the download to start. So I recommend you download the recent stable version. That'll go away, and once you've done that, we're going to have to burn this to an ISO or create a network boot, stick it on a CD, however you want to do that. Do note that you don't just have to put this onto a physical machine, you can also do a virtual TrueNAS as well. You can run this as a virtual machine. As I've mentioned before about using things like TrueNAS or your NAS as a hypervisor, the same sort of things apply. If you're going to virtualize this, do bear in mind that maybe what happens if you reboot the host, it's going to reboot your NAS, especially if you're going to be using that in real time. That's not a great setup. So do think about how you want to deploy this. Now for this video, I am going to be deploying this within Proxmox as a virtual machine. The reason for that is twofold. Firstly, if you are going to do this as a virtual machine, hopefully this will give you a hand. And also in my previous video, I give a direct breakdown of that entire process, including the entire build. So do go and check that out. Outside of that, for those who are going to do this on their own bespoke hardware, once you've got past the VM configuration, the actual user experience of installing this thing is exactly the same. So let's now hop into that and let's get it started. Now in Proxmox, I've created this TrueNAS virtual machine. There's a couple of things I just wanted to discuss about what this is actually comprised of before we boot into it. So I've tried to replicate what I think would be a modest DIY home lab NAS. And you can see here that I've got 8 GB of RAM, it's 6 cores, and it's got a number of drives. We've got the installation media here for TrueNAS, which would typically be, say, your USB stick if you're doing this with a physical device. I've got one drive here which I'd typically put the operating system, i.e. TrueNAS itself, onto, and then 4 other drives which could be 4 NVMEs, 4 SSDs, or 4 traditional hard disk drives. Now, if you're doing this in a virtualized setup, I would refer to my previous video whereby I used a HBA, a host bus adapter, to physically pass these drives through to TrueNAS. This is just emulating that 4-disk setup. This is not what I recommend. With a host bus adapter, the actual physical drives would be attached to a PCI device, and then simply you would attach the PCI device instead of these drives to TrueNAS. But all I'm doing here is demonstrating a configuration with TrueNAS whereby you would have more than one drive because we're going to be creating a RAID setup. So if you do want to do the bare bones with pass-through, do go and check out my previous video. That has recommendations for the hardware itself, plus exactly how to pass that through using an HBA. Anyway, with that aside, let's get into booting this up and starting the installation process. So when we start the installation process, this should fire up and we should get straight into TrueNAS. So for this installation, we're just going to do the start TrueNAS scale installation. And when we hit return, hopefully it should ask us now where we want to install this operating system, because it's going to have found a number of drives. So the first thing that we're presented with is the 4 options. Well, 2 really. We've got the installation or upgrade option, and we've got access to the shell. Now, we're just going to do the installation and upgrade, but sometimes it is necessary to go into the shell, especially if you've got some exotic configuration. Perhaps you need to add some additional drivers, etc. So we're going to hit the installation, and here you can see those drives that I mentioned before. The first thing it's going to ask us to do is, where do you want to install TrueNAS? Now, it's probably a good idea to actually mirror the installation, albeit you don't strictly have to, and you can refer to backups, which we'll set up later in the video, where you can take a backup of your TrueNAS, and if it does break, you should be able to restore that to a new machine. Don't worry about your pool. You can even translate pools, RAIDs pools, between different operating systems, so a pool should work on any ZFS machine. In this instance though, I'm just going to install it on this SDA, and you might want to think about what medium you put this on. So for example, the 4 drives down here, which may be a hard disk drive for example, you might want to make the one that you install TrueNAS onto maybe an SSD or an NVMe, so it boots up faster, does updates faster, all of those sorts of things. Plus as well, if you're going to be running things like Docker, you might want to run those just on that operating system as well, albeit there's obviously advantages to running it on the RAID setup that you're going to use as well for things like redundancy. So with that setup selected, we should be able to hit OK. It's going to give us a warning that everything's going to be deleted. That's fine. Now we have some options around the authentication method, but I'm going to go with the administrative user, the TrueNAS admin. Now we need to set up a password for this, so let's set up a password and then we should be able to move on to the next step. Then we're going to be asked whether we want to enable EFI for boot. Now, as you can see, this is dependent really on the hardware you're using. So if you've got something that's quite old, doesn't support newer features of EFI for example, make sure you hit no, otherwise click yes. Now it's going to go away, format that drive, install TrueNAS, and I'll see you when this is completed. So now that's completed, it's asking us to remove the installation media. So we'll do that, we'll hit reboot, and hopefully we should then boot into the shell for TrueNAS, and we can also then see the IP address to access this through the web UI. So if we reboot the system, it should now go back into the operating system for the first time. Here you can see it's automatically going to boot into it, and we do have some advanced options if we wanted to interrupt this first boot. Fingers crossed, it will now go through, it will boot, it should pick up a network address from a DHCP, and then hopefully we can access the CLI. The first boot up can take a little while. As you can see, it's configuring a ton of stuff in the background, but we should be up and running in a few seconds. So now that's completed, you can see here that we're presented with the CLI for TrueNAS, and this can be handy if you do need to get in and do some debugging, you need access to the underlying operating system. But the bit really that we're interested in is up here, this IP address here. So we'll go to the 192.168.200.132 and we'll put that into our browser. Going to that page, we're going to get a cert error just because it's using self-signed. So as you probably saw during the installation, the default username will be TrueNAS admin, and the password is what you set during installation. So hopefully clicking login, we should get into the dashboard. And perfect, yeah, here you can see that we've got the dashboard for TrueNAS for the first time. Right off the bat, we can see what we pretty much expected to see. We've got the CPU, it's picked up here, we've got the memory here, and we've got some preliminary stats for how this is running. Now, because this is running in a virtual machine, it's not going to pick up things like the temperature, but it should pick up some of the CPU usage, etc. Albeit that's going to be stood at 0 because it's not actually doing anything at the moment. So a quick look around here before we build a pool and create, say, a share, for example. Everything we need to do is on the left, essentially, and it works kind of in a descending order. So let's have a look at our storage. We don't have a pool. Now, we don't have a pool because we haven't created any VDEVs from our drive yet. Datasets, well, we haven't got any datasets because we haven't created a pool yet. We haven't got any shares because we can't use a pool to put them on. And we'll work through that process in a moment to go and correct all three of those areas. Other aspects we might want to look at are data protection, so we can have backup tasks, and it's great to see that this is now baked into TrueNAS. The network as well, it will show you some statistics for your network, so you can add various different adapters, you can tweak the settings for them, set static IP addresses, which I definitely recommend. We can have some credentials in here as well for different users, groups, access control lists, etc. And if you're using this in more of a production environment or you have multiple users in your home lab, you'll definitely be wanting to set up multiple users, each with their own credentials, so that they can basically have their own separate area on this TrueNAS share. Now, as I've mentioned in the initial description of TrueNAS, we can actually set up virtual machines on here. I'm not going to be doing that, but basically it behaves similar to other hypervisors. We can install virtual machines and use them as you would anything else. Apps are basically what I was talking about when we had, say, Docker or Kubernetes, so you can actually install that onto TrueNAS itself. You can say click the available apps, and then there's a ton of community stuff, but it will also take into effect just any sort of Docker Compose file as well that you want to run on there. So first thing we want to do is to have a look at the disks. So if you click here, you can see the disks that we've actually got. It's those 4 disks, they're currently unutilized. So basically what we're going to end up doing is creating a pool out of these drives that we'll share with the rest of our network, as in this instance we'll use an SMB share, but it could be anything, and you can also have multiple different protocols all using that same pool. So clicking back on storage, let's create that pool. Now I'm just going to call this one test. We'll click next. Do note that you can turn on encryption here or not. I'm not going to do it for this video. Next, we get to decide what type of VDEV we want to do. Remember, this VDEV stands for a virtual device, and what we're doing is basically joining all 4 of those what would be physical drives. In this case, they're virtualized within Proxmox, but they would form one virtual device made up of those 4 physical devices. And that's where we basically get the different RAID options. Now, since I've last done this, there's actually these new options down here for D-RAID. Now, this seems to be a ZFS feature that boosts resilver speed and load distribution. And it seems to be, from reading the documentation, designed for sort of higher capacity, bigger NASs. If you're wondering, the resilvering process is what happens basically when you add a drive after one has died. So you're replacing a drive, it has to put all that material back onto that device and basically replicate the failed drive. That can take a long time depending on how big your drives are within your array. Typically, most people will go for this RAID setup here. Now, remember, I've got 4 drives, so maybe I just want a RAID 1. Remember, the number denotes how many drives can be redundant, i.e. how many can fail without losing data. So if I did 1, 1 can fail, and the 3 would still be there. If I did 2, 2 would be able to fail before data loss, and 3, you get the idea. So with only 4 drives, maybe RAIDs 2 is the right balance depending on what type of data you're on here, or maybe 1. Remember, however many drives you set up for that parity data, you're going to lose that storage. So I've got 4 32 gig drives here, so what's that, 128 gigs max capacity? But basically remove 1 if you're going to be doing RAIDs 1, so I've got 3 times 32 or 96, and if you're going to do 2, you're going to halve that, so you're only going to get 64. Just to prove that point, I'll go with RAIDs 2. So basically, of those 4 drives, you can see here now the total raw capacity is going to be 64, even though actually we're putting 128 into this. Now, there are more advanced configurations you can do with this, and you can see down here that we can actually specify what width we want and the number of VDEVs. Now, this has automatically selected that for us, but you can do manual disk selection down here. And if you had more drives and they were spread out across different planes, etc., you'd be able to choose exactly which disks you want to use for this pool. Now, you might also have different size devices, different speeds of devices, etc. And you'd be able to cater this to whatever you're needing to do. You might have different pools for different use cases. You might have a fast pool for video editing and scrubbing, a slow pool for video archiving. I'm just going to go with this one for now to keep it simple. I'm going to hit next. Now, the next step is to talk about the log, or more specifically the ZFS log, sometimes called the ZLog. Now, what this does is, as it says on the tin, it improves the speed of synchronous writes. So if you're doing a lot of write data, this acts as a bit of, say, a cache. Now, it's a bit more complicated than that, and I do recommend you go and read up on the documentation as to how this works. It's not like your standard caching would do on, say, a PC. Now, you do get some options here, and this whole thing is actually optional. Now, when I set up my TrueNAS, probably 7 years ago, I never actually set this up, and that's because I've only ever used it really for archiving. When I get onto the HL15, I might change that and mess around with it a little bit more because I am keen to see what performance benefit that has. But the actual way in which I use my NAS probably won't change that much. So for this video, we're not actually going to set this, but we will have a look and describe the settings, and you can choose if this is something that you want to enable. Now, if you think back to a couple of minutes ago, we actually showed that we've got 5 drives on this virtual machine. One of those drives is where the operating system is installed, and the other 4 we've now just put into this pool, the one we're creating. So we can't actually select a drive to put this on. Effectively, what you would need to do is add another set of drives or whatever, and then put this onto there. So it's kind of a separate array that acts as a cache. Again, you get the same options for that manual disk selection. So I'm going to click next, and then we're going to get onto this spare. Now, this is really cool because it basically sets up, pre-configures some replication failover in the event that your main VDEV fails. So as I was saying before, the whole point of really ZFS and TrueNAS in a way is to make sure that your data is resilient and always available. So if your main VDEV, so think about this as our main pool of 4 drives, we could have another backup of 4, and if that main one fails, it's going to seamlessly switch over to the other one, hopefully. Now again, we don't have that option because we're using all of our drives just in that first pool, but say if I doubled up and I added another pool, which you can do, you don't just have to initially set this up and that's it. You can add more and more drives as you go. So another reason why I really like TrueNAS and ZFS in particular, because you can keep adding drives to it, keep building up your array as and when required. So we'll click next, and then we get onto the cache. Now again, the cache, you might be thinking, what's the difference between the zlog and the cache? This basically uses a level 2 arc, and the way that that works is the opposite of the zlog really. This is for read, so a bit like you would store something in RAM to read it quickly. That's the same sort of thing here. Again, because we don't have any drives available, we can't actually set this. But if you wanted to add another disk drive to ZFS, you could do that, and then you could have that as a really fast sort of read buffer. So we'll click next, and then we get onto metadata. Now again, this one is also optional, and again you can see that each of these options is specific to a certain type of performance. So you might not even need all of these if you want to take advantage of it, and you could possibly use a single NVMe drive with multiple partitions to actually speed this process up. So here you can see that the metadata is used to speed up metadata and small block input-output operations. So again, we can't do that because we haven't got anything. And finally, again, we've got that deduplication. This is to store deduplication tables onto separate VDEVs. Again, we don't have another VDEV, so we're going to skip over this. Then we should get onto the review. So basically, we're going to create one RAIDs 2 4 times 32 gigs with an estimated usable capacity of 64 gigs, which is half of that total capacity. So let's say create the pool. It's going to confirm, it's going to erase everything. We're going to click continue. This should be pretty quick, and then we should see that pool now reflected on screen. So here you go, that's now completed, and we've ended up on something like 59.14 gigabytes, and you can see that everything's now healthy. Now what that means is we can go to datasets, and we can see that test dataset that we created, and we've got a number of options that we can do here. So the first thing we could do is go in and have a look at the details and edit those. We could look at the dataset management. We can do some data protection, i.e. take a snapshot of that data as well. We can also, in the bottom right behind my head, albeit you'll probably want to do it in a different space, we can set some permissions for who has access to this dataset. Now what we can do is create multiple datasets. So it's usually a good idea to create sub datasets for all the different things. So let's create a new dataset, and let's just call this one pictures. And as you guessed, we'd put our pictures into this dataset, which we can share later on. We might also have another dataset, and that might be movies, and you can just create basically as many datasets as you want. And then you would create basically shares per each one. I've actually put that in the wrong position, so I'd want to go back and edit that, but you get the idea. So with it fixed, it would look like that, all sitting underneath this chief dataset up here. Now, as you can see here, if we look down the bottom right, both of these have the owner of set to root. So it's probably a good idea to go through to the credentials, go through to your users, create a new user, fill in those details, and then you could assign different users, i.e. different people in your family, your business, etc., access to those different data sets. I.e. if it's something like image or machine backups, maybe only your admin should have access to that. If it's a shared working repository, maybe all employees can have access to it. You get the idea. So now we've set up a couple of data sets, we can actually go down to the shares. Now by default, none of these are running, but if I go to the SMB share and I click add, we should be able to now choose which share we want to use. So it's on the /mount test, and these are actual physical locations on this box. If we went into the command line, we'd be able to see all of this stuff. So I'm going to say pictures, and it's going to throw up a warning about not having an SMB user created. So we will need to go and create that. The reason for that is traditionally you used to be able to use the root admin account for SMB, but obviously that's not good from a security standpoint. So let's quickly go back now to our users, and we'll create a user for SMB. So click in credentials and then click in users. Let's click add. I'm going to create myself. I'm just going to call this one James. We're going to create a password, and we'll need to remember this password for later on when we connect to it via my Windows machine I'm on now. Now filling that in, we can see that there's quite a few options we can do here. So we get control over the user ID and groups, and anyone who's familiar with Linux, we get full control over that. I'm also going to create this as a new primary group, which basically creates a new group with this name. We can also then use that later. So for example, if we weren't just creating, say, people with names, we could actually create groups and add them to it. Now, when we create this, it's going to create a new home directory, which will default into this area here. We can change that if we wanted to, and we're going to specify what home directory permissions that user's got. So just for a standard user, you'd probably expect to be able to read, write, and execute your own user's data. We can also add, upload SSH keys if we wanted to, give shell access. We're not going to do that. This will just be, say, a standard user, a non-admin user. And then we can also have some other options. Crucially, at the bottom, you'll see whether or not this is an SMB user, which is the issue we faced previously. So I'm going to click save, and then it should over here create that James user. Perfect. So now we should be able to go back to the shares. We should be able to click add, and then we should be able to create this share. It hasn't thrown up that message. So let's click mount, let's click test, and we're going to save the pictures first. So pictures, default share parameters, we can obviously change this and tweak it to whatever we want, tie it in with whatever ACL we want to have, and then we can click save. If we want to, we can go in and configure the ACL, that access control list, and it's also saying whether or not we want to start this service. So I'm going to click start. Now editing the ACL, it's a good idea, I always find, to do the permissions editor, because it just makes it easier, especially if the first time you're using this. Now by default, we shouldn't actually need to change any of this. When we selected this as an SMB user, it should have automatically made it work. So now with the very basic setup, we've got a user with SMB, we've got a share on a data set using some storage. You can see here we've got SMB configured. We should be able to connect to this now through my Windows machine. So on Windows Explorer, I've clicked to map a network drive, and we basically need to put in now the IP address and the share that we want. So that path will look like this. We've got / the IP address, which is the one up here, and then that pictures, which is this one here, that data set. Now it's probably a good idea to reconnect at sign-in, so when your machine boots up, it'll automatically connect to this network drive, and you will need to say connect using different credentials, unless you happen to have exactly the same credentials for your Windows machine as this share. So when we click finish, we're going to have to add in now our username and password. This is the username and password that we created, not the TrueNAS login. This is the one we created with that user on credentials that is associated with this share. So for me, it would be that user of James, and you can also remember this, probably a good idea, so that each time you don't have to put your credentials in. And if we hit OK, it should now open that up in Windows Explorer. So here it is. You can see that we've now mounted this to my Windows machine under the drive letter of Y. So this basically acts now like any folder on your PC, albeit it's now remotely served up by your NAS. And that's great. You've probably seen this if you work in a business environment where you've got multiple shared drives, each between different team members. So now you should have the very basics of how TrueNAS works, how to set up a share, how to share files, etc., create users. I'm going to end the video here, but basically it's a process of just replicating this. Instead of doing SMB, you could go ahead and create, say, an NFS share. You could then mount that within Linux and basically do the same thing. You could then use these shares within your hypervisor. You could then use these to store virtual machines. You could store your movies and then serve them up in something like Plex. You get the idea. So thanks for watching, everybody. Hopefully that's given you a quick primer on how to build your NAS, either what to look out for when you're going to buy one, or some of the considerations around hardware and software when you're actually going to do a DIY one yourself. As always, you know I love the DIY route, so that is the way that I recommend you go. If you do have questions, please drop them below or hop onto the Discord and we'll get those answered for you. In upcoming videos, I am going to be checking out some of the products I mentioned, really keen to see where those fall within the stack, and more crucially, do I recommend them or not. Anyway, as always, thanks for watching this video. If you've liked it, give it a thumbs up, hit that subscribe. I'll see you on the next one. Take care, everybody.